Welcome back to Connect and Transform. This video starts a new sub-project. Similar to the most recent project, we are dealing with graphing and SVGs. This project is a brand new file and its purpose is to produce pie or donut charts. If you remember from the last project, its canvas size was 1200 wide by 540 high, and the visual rendering area inside of that was 432 high by 1080 wide. So that's why I've chosen to start with a 540 by 540 canvas, and then I'll target a 432 by 432 maximum pie chart rendering area. And then in the future, if we want to extend the width and include a legend of labels, then we'll do that in a future video. So we have our SVG root element here along with some boilerplate attributes for XML namespace, which is required so that the browser knows how to process the document. We need the XML NS xlink attribute in order to read URL parameters in the future, similar to the last project. We've defined a width and a height, and then we've defined our view box so that if we have this SVG document embedded in another one and scaled to a different size, it behaves as we expect. Inside our root element, we have a script tag. We've given it a type just for good measure. And we've defined here some sample data to start with. It just has data values and colors. So this is red, green, blue, and a dark gray. And the values, as you can see, 1, 2, 3, and 4. And then we're going to call a function we're calling load graph data, and I've created the skeleton of that function here. So let's get to work. We're going to have a number of constants. So we're going to have a constant for our SVG element, and that's going to be document.getQuerySelector. You could also use getElementById and put an ID on the root. But I'm going to say document.querySelector by tag name SVG. And then we're going to track a couple other things. So we're going to create a constant to store the SVG namespace string, and that is going to be our last constant, svg.getAttribute. And we're going to get the attribute XMLNS. Our next two constants are going to be the canvas size. So that's going to be canvas width, and that's going to be equal to, now I'm going to parse a float here just in case we decide to add units to these numbers. So if I were to say 540 pixels, for example, by having parse float here, that should still work. And we're going to be looking at svg.getAttribute width. I'm going to duplicate that line and do the same thing for height. Okay, so now we've got our canvas width and height. Now we're going to store a couple of numerics that have to do with like circles and zooms and how it is we're going to render this. So when we eventually mouse over different components of the pie chart, I want to have them kind of shoot out from the center point of the circle. And I'm going to accomplish that by doing a transform and scaling the element. So I'm going to define that zoom value here. And I'm going to say that it's 1.08. And there's a reason for that. Remember that in our last project, the rendered chart portion of the total canvas was 432 high by 1080 wide. So keep in mind that 432 high. So if we say 432 and we divide by 1.08, we get exactly 400. So it's just a nice even number to work with, and that's the only reason that I chose 1.08. I might adjust this in the future, but at least for a first pass, it would be nice to know that we're going to create a pie chart that at its resting state has a diameter of 400, and in its zoomed state, it would stretch out to be the equivalent of a diameter of 432. Of course, that would only be true if you had a slice of the pie chart that was 50% or more of the total pie. So that's kind of a preview of what Zoom will eventually be used for, but not in this video. So we're moving on. We're going to track diameter. And so as I just described, that is going to be our 432 target rendering, maximum rendering height divided by our zoom. So that's our diameter, which for now, given these numbers, should be exactly 400. Now we're going to have a few more constants. Let's try to spell that correctly. So we're going to track a circumference. And so that is going to be our diameter, which happens to be 400, times math.pi. So now we've got a reference to circumference that we can use in future expressions. So the next thing we need to do is we need to track the total of the values. So like if you look back at the data here, the values are 1, 2, 3, and 4, and we know that the value is 10, but we need to calculate that total so that we can get the proportion of each of these. And then we're going to use that proportion to calculate how much of the stroked dash array applies to that piece. Because we're going to use the, we're going to be creating a bunch of different circles with a stroked dash array of a certain size, and then with a certain amount of break. And so basically what it works out to is we're just producing pie slices, even though we're using circles. So after we've got the circumference, we are going to calculate this total that would store the total of all these data values. So we're going to call that total data value. We'll initialize it to 0. And then we're going to say graph data values dot for each. Okay, and here's where we're actually going to add all these things together. Okay, and then we need another variable to track the total stroke dash array offset. And this is so that we can offset each corresponding piece by the right amount. Okay, so now we get into actually creating an element. So const, and let's see, we're going to call this container, and we're going to attach this directly to the SVG. And so this is going to be a group G tag. So that's going to be document dot create element ns. It's going to be a G tag, but we also need to pass in the SVG namespace string. Okay. So that's what we've named our element. So let's set an attribute here. And what we're going to set on this is we're going to set the style attribute. And we're going to transform it with a translation. And this translation is going to be half of the canvas size. So in other words, we're going to take the things that we create at the coordinate 0, 0, and we're going to shift them over to be centered in the canvas. So we're going to pass in 2 calculated numbers here. And we could just do the math. We could just look at this and say, okay, 540 divided by 2, that's 270. But we're going to use our canvas width and our canvas height numbers. Okay, so this will position the container at the center of the canvas, and then we've got to add the container to the canvas. Like that. Now maybe before we proceed, I'm just going to refresh here, make sure there are no typos. And you can see here in the HTML that there is a group, but there's nothing inside of it. So we're not seeing anything yet in the browser. Okay, so after we've created and attached our container, we're going to have a loop where we go through all the data points and we create our pie slices. So we're going to say for, and then we'll have a variable d that we increment, and we're going to start it at 0, and d is going to be less than some length, so that's going to be graph data dot data values dot length. Okay, so now inside this loop we're going to have some more constants. Like I was mentioning earlier, we need to map these values to something that relates to the actual circumference. So let's go back to some of these constants here. So we know the diameter is 400. 400 times a little more than 3, so our circumference is somewhere above 1200 units. Maybe that's pixels, maybe it's unitless, doesn't really matter. So circumference is a little greater than 1200. Now these data values are 1, 2, 3, and 4. So we need to map them proportionally to that amount of units so that we can use that mapped proportional value when setting our stroke dash array. So we're going to call this mapped data value. And that is going to be equal to, it's going to be the circumference divided by 2 times and then our proportion, so that's going to be graph data dot data values at position D times divided by the total data value. Oops, wrong variable. Okay, so here we've got graph data over total data value, so that's proportionally what we're looking for, and then we are mapping this to half of our circumference. We could have just made a variable for radius, but I don't think it's necessary. And then there's one more constant. I think we're almost done with the constants. So we need to keep track of the dash offset. So not the total dash offset, but the dash offset for this particular pie piece. We're going to start that at 0. And then basically what we need to do is we need to add, well, in this case, subtract, but we need to magnify by a certain amount the dash offset of every piece that has already been processed. So let me just copy the guts of this. Maybe I'll change D to O for offset. I don't know, we could name it anything. And so what this is going to say is if, so we're going to say if O is less than D, in other words, if it's a pi piece O that we've already processed, because D is the current pi piece that we're getting ready to process. So if O is less than D, then we're going to say dash offset minus equals some amount. And that amount is going to be circumference times, and then it's going to be basically the same expression here. We'll make sure to replace D with O. Okay. And then the last thing we need to do, well, in my first version of the code, I had then gone and divided this by 2, but maybe I'll just copy what I did here. So we'll just say circumference over 2, and that should work just the same. And then once we're done with that, now we're going to update our total dash offset. Okay, so now we've got all of our constants and helpers, and so now we're just going to be creating circles, which will render as if they are pi pieces. So we're going to call this pi slice, and we're going to be creating a circle. I'm just going to copy that and change this G to a circle. Okay, so we've called it pi slice. Now we're going to be setting a number of attributes. Okay, so what are we going to be setting? We're going to be setting things like ID, class name, radius, X and Y. So ID, class. Now our class is just going to be pi slice. Our ID is going to be pi slice underscore, and then we'll give it the number D. We're going to need a radius. We're going to need an X and a Y center point. We'll get to those values in a second. We're going to fill it. We will set some initial opacity. And then we're going to set a bunch of attributes around the stroke. So we'll have the actual stroke color. We'll have the stroke width. And then we'll have stroke dash array and stroke dash offset. And so these two in particular, and I guess also the stroke width, but basically the stroke, this is all going to work the magic around basically creating pie charts without us really having to do any low-level coding. And then after that, we would append. So we will append the pie slice to the container. So container dot append child pi slice. Okay, and I think that pretty much does it. Let me just double check and make sure I'm not missing anything. I don't think so. So let me just go ahead and zoom in a little bit because this code was smaller than I expected. So for our radius, that's going to be 100, but I think I want to use maybe this diameter. So we know the diameter is 400. So this is going to be diameter divided by 4. And you might be thinking, well, why is the radius diameter divided by 4? Well, because normally it's diameter divided by 2. Well, it has to do with how the stroke gets painted onto the canvas. So if you imagine, so the stroke doesn't get painted onto the outside. Like imagine like a section of a tree. The stroke doesn't get added as like the bark around it. The stroke grows in both directions. So it grows towards the center point of the circle and away from the center point of the circle. So we really need the center of the stroke to be at a different place than the actual true radius. And then Cx and Cy are going to be 0. So we are constructing these things around the point 0, 0, the origin point, and then we are translating their location by some amount. Fill is going to be none, which is important to allow things to stack properly and allow them to still be selectable. Opacity, we'll just default that to 0.75, which I think was our default in the last project as well. Now the stroke is going to be the color that we've defined. So that will be graph data.colors at position D. Our stroke width is going to be diameter divided by 2. And then for our dash array, that is going to be, so we're going to give it two numbers, x and y. And x is going to be our mapped data value, and then y is going to be the entire remainder in units of the circumference. So in other words, the first number is the part that should be shown, and the second number is the part that should be skipped, which is everything else. So that's going to be mapped data value and then the second number is going to be circumference minus mapped data value. And then our offset is going to just be our dash offset that we've already calculated up here. So that's just the running offset of every pie slice that has already been calculated up to that point. So let me save and let's see how many typos we made. Okay, so it doesn't like the translation, so that must require a unit like pixels. So let's add those in. Let's save, refresh. Okay, and there we go. So we've got red represents our first, so that's 1. Green represents our number 2, so 1, 2, 3. And then the blue is 3, so 1, 2, 3, 4, 5, 6. And then our gray is the remaining 4. Now let's play with the data real quick. Let's say that we're doing like 1 and 99. So let's say we only have 2 values. Well, there we go, 1 and 99. Let's swap it around. 99 and 1. Okay, let's do half and half. We'll just say 99, 99. And I could just as easily have said 9 and 9. And we see that that's working. Let's try thirds. It doesn't have to be the number 3, it just came to mind. And there we go, we see that it's working. So it starts at this rightmost point by default and then shifts around. If I wanted it to start at the top, then I would probably want to translate the entire container by doing a rotation. So let's do that now. So let's just say 90 degrees. Now this might need to be negative 90. So we'll save that, refresh. Yes, it needs to be negative 90, or it could have been 270. So we'll save that, refresh. Okay, so now we're going to start at the top, at the 12 o'clock position, and then work our way around clockwise. And to demonstrate that one more time, let's just say we have a value of 1 and 80. So it's a value of 1. Actually, to make that more clear, let's say 10 and 80. There we go. So we're starting at the top. We're working our way around clockwise. But that's it. So we've created a pie chart using the functional properties of dash array and dash offset and strokes. So we'll build this out further in a future video. Thank you for watching.